Okay, good morning. Some MCQs are related to colligative properties and chemistry. Colligative properties depends on number of solid particles which is not a colligative property. Relative lowering of vapor pressure, elevation of boiling point, osmotic pressure, rate of vaporization. Rate of vaporization is not colligative property. Colligative properties are applicable to ideal solutions, not for ionic solutions, molecules, and suspensions. Relative lowering of vapor pressure is given by P minus Ps over P equal to N over N plus N. Boiling point elevation formula delta TB equal to Kfm, delta TB equal to Kbm, delta Tf equal to Kbm, delta TB Kpm. Correct option is delta TB equal to Kbm. Boiling point elevation formula delta TB Kbm. Freezing point depression is delta TF Kfm delta TF Kbm. Both A and C. Freezing point depression, boiling point elevation. The unit of osmotic pressure, atmospheric pressure in Pascal, mmHg. Band of factors accounts for association, dissociation, both A and B. If a solute dissociates, band of factor is greater than 1. If solutes associates, band of factor I is less than 1. The boiling point of solution is always lower than pure solvent, higher, same, sometimes lower. Boiling point of solution is always higher. Freezing point of solution is lower. The most accurate qualitative property of molar mass determination, osmotic pressure, boiling point elevation, freezing point depression, vapor pressure, osmotic pressure. The most accurate qualitative property for molar mass determination, osmotic pressure. Raoult's law is applicable to ideal solutions, non-ideal solutions, colloid suspensions, ideal solution. When a solute is added to a solvent, vapor pressure, when solute is added to solvent, vapor pressure increases, decreases, remains same, first increases, then decreases. Correct option is option B, decreases. When solute is added to a solvent, vapor pressure decreases. A semi-permeable membrane allows solute only, solvent only, both neither. Semi-permeable membrane allows solvent only. Osmosis is flow of solvent from solution to pure solvent, solvent from dilute to concentrate. Correct option is option D, A and B. Osmosis is flow of solvent from solution to pure solvent, solvent from dilute to concentrated. Reverse osmosis occurs when pressure is greater than osmotic pressure. Reverse osmosis occurs. Pressure is greater than osmotic pressure. Which solution will have highest osmotic pressure? calcium chloride, 0.1 molar calcium chloride. The relation between the osmotic pressure and concentration pi equal to CRT. Cryoscopic constant is used in freezing point depression. Cryoscopic constant is used freezing point depression. Ebullioscopic constant is used boiling point. Bandt factor I equal to 1 for glucose, non-electrolyte. Colligative properties depend on molarity. Molarity is independent of temperature. Elevation in boiling point is proportional to molarity. Relative lowering of vapor pressure is equal to mole fraction of solute. Relative lowering of vapor pressure is equal to mole fraction of solute. Relative lowering of vapor pressure is equal to mole fraction of solute. 1 molar solution means 1 mole solute in 1 kg solvent. Which properties used in antifreeze? Freezing point depression. Freezing point depression. Colloid should no colligative properties. Osmotic pressure increases with temperature and concentration, both A and B. Hypertonic solution has higher osmotic pressure. Hypertonic solution has higher osmotic pressure. Isotonic solution have same osmotic pressure. Higher molar mass solute gives lower. Strong electrolytes show higher Bandt factor. Vapor pressure lowering depends on solute mole fraction. Azeotropes deviate from Raoult's law, which is used to determine the molar mass of polymers. Osmotic pressure. Bandt factor. Observed expected colligative property. The freezing point of seawater is lower due to presence of salts. Pure solvent freeze at higher temperature. Molality unit mole per kg. Increasing solute concentration cause vapor pressure to decrease. Which membrane is used to desalination? Semi-permeable. For association, I is less than 1. Osmotic pressure for 1 molar glucose at 300 Kelvin, 24.6. So you can calculate phi equal to Salting out is related to vapor pressure lowering, freezing point, osmotic pressure, solubility reduction. The constant Kf depends on solvent only. Colligative properties are used to determine molecular mass. Colligative properties are used to determine molecular mass. Raoult's law is applicable for ideal dilute solution. When a solute is added, the boiling point increases. 1 molar solution contains 1 mole solute in 1 kg solvent. Osmosis stops when osmotic pressure is applied. Bandt-Hoff factor of potassium sulfate is ideally 3. Greater the solute concentration, greater the osmotic pressure. Which solution deviates from ideal behavior? Sodium chloride. Or semi-permeable membrane allows passes of solvent. Boiling point elevation depends on number of particles. During dissociation, colligative effect increases. Cryoscopic constant relates to delta T of 0.1 molar sodium chloride solution freeze at lower temperature. Sodium chloride is electrolyte that dissociates in 2 ions. Hypertonic solution, higher osmotic pressure, Bandt-Hoff factor of calcium chloride ideally 3. Pressure applied to stop osmosis, osmotic pressure. Elevation in boiling point is molarity. Elevation in boiling point direct process to molality. Molality depends on mass only. Molality unit, mole per kg. Osmotic pressure of 1 molar solution at 300 Kelvin, 24.6 atm. Which shows the highest colligative effect? Calcium chloride. Boiling point elevation constant depends on solvent. In reverse osmosis, water flows from solution to pure water. A solution having lower osmotic pressure is called hypotonic. Pi b equal to nRT is equivalent to gas law analogy. If I equal to 0.5, the solute is associated. This is solution value of I greater than 1, I equal to 1, no change, less than 1, association. Highest freezing point deflation when Bandt-Hoff factor I increases. Isotonic solutions have same osmotic pressure. Colligative properties do not depend on chemical nature. Delta TB equal to IKB. Gamma represents real solution. Vapor pressure lowering formula. Which membrane is artificially made? The osmotic pressure of 0.1 molar sodium chloride higher than 0.1 molar glucose. Molar solutions are used because they are volume independent. temperature independent. So both A and B. Kf for water 1.86. Kf for water, Kb for water 0.52. Lowering of vapor pressure occurs due to decrease in escaping tendency. Seawater freezes at lower temperature. Depression in freezing point proportional to molality. Osmotic pressure is used for molar mass of polymers. 1 mole of associate to 0.5 mole, 0.5 equal to number of particles in solution over number of formula units, the joule. Osmotic pressure of isotonic solution, same, I equal to 1 for no dissociation. The process of osmosis is spontaneous. If pi decreases, concentration decreases. Reverse osmosis used in purifying water. Vapor pressure lowering is useful for molar mass. 1 molar glucose solution contains 1 mole per 1 kg. Molar freezing point depletion constant. Molar boiling point constant, Kf is also called molar freezing point depletion constant. Osmotic pressure unit, ATM. Depression in freezing point of electrolyte greater. Boiling point of a solution is higher than solvent. Abnormal colligative property, delta Tf into IKF, Yam shows abnormal colligative property. Osmosis occurs due to difference in concentration. For 1 mole urea, I equal to 1. Freezing point of 0.1 molar solution will decrease. Freezing point depression is a colligative property, meaning it depends on the number of solid particles added to solvent, not on the nature. Delta Tf equal to Ik of delta Tf decrease in freezing point, band of factor, Tf freezing point depletion constant, M molality. When a solute is added to solvent, it disrupts the formation of solid structure. This makes freezing more difficult, so the solution must be cooled to a lower temperature to freeze. Strong electrolytes gives higher Van der factor. Solution with same osmotic pressure, isotonic, molecular mass is inversely proportional to delta Tr. Osmotic pressure decreases when temperature decreases. Van der factor corrects non-ideal behavior. Reverse osmosis requires external pressure greater than pi. Solute which associate benzoic acid. Electrolytes have higher colligative effect. Non-volatile solute always lowers vapor pressure. Molar mass by boiling point elevation moderately accurate. Cryoscopic method is based on freezing point. Pi proportional T. If C constant, solvent vapor pressure at in point is lower. In hypertonic solution, solvent flows out of cell. Adding solute increases entropy. Isotonic solution have same pi For dilute solution, molality and molarity are almost equal. Salt in water lowers the vapor pressure due to solute-solvent interaction. Vapor pressure lowering is colligative. A solution with greater delta Tb has more solute. A solution that causes cells to shrink is hypertonic. Higher boiling elevation. Higher Kb means higher boiling elevation. Molar mass from pi uses moles, volume, temperature, all. Henry's laws applied to gas-liquid system. For electrolytes observed, delta Tf is the greater degree of dissociation. Hypotonic solution has low pi, the least accurate method, vapor pressure lowering. Increasing solute decreases freezing point out. A semi-permeable membrane is used for osmosis. If vapor pressure difference increases, concentration also increases. Value of I is greater than 1 indicates dissociation. Osmotic pressure is directly proportional to number of solute particles. Solution with same freezing point is isoosmotic. Refrigeration use freezing point depression. Example of non-volatile solute, urea. I is greater than 1 indicates association. Delta Tf increases with molality. If solute is volatile, Raoult's law modified. When solute is added, vapor pressure always decreases. Osmotic pressure phenomenon, thermodynamic. The slope of pi versus C graph is RT. Freezing point depression used for antifreeze. 1 mole solution is concentration unit. Dissociation increases colligative effect. Vapor pressure of solution is always lower. Example of non-electrolyte glucose. Isotonic intravenous fluid 0.9% sodium chloride. Highest osmotic pressure calcium chloride. Association reduces colligative property. Osmotic pressure is measured using osmometer. I observe delta Tf or calculate delta Tf association dissociation. In a solution, adding a solute increases. In a solution, adding solute increases entropy. Lower vapor pressure solution boils at higher temperature. A solution with lower vapor pressure requires more heating for its vapor pressure to become equal to external atmospheric pressure. Since a liquid boils when its vapor pressure equal to atmospheric pressure, a lower vapor pressure means it must be heated to a higher temperature to reach that point. Cell is hypotonic solution, swells. Kf for benzene is 5.12, Kb for benzene is 2.53. Reverse osmosis used in desalination. Blanto factor of 0.1 mole sodium chloride is approximately 2. Delta Tf is proportional to molality. Vapor pressure is highest for pure solvent. A stronger solution means lower vapor pressure. Boiling point elevation used for sugar industries. A semi-permeable membrane, example, cellophane. Osmotic pressure can purify brackish water. A non-electrolyte solution has osmotic pressure equal to 1. Degree of dissociation increases with dilution. Association occurs in organic acid in benzene. Abnormal molar mass occurs due to association, dissociation. Lowering of vapor pressure occurs because solute occupies space. Osmotic pressure varies with temperature. Kf is property of solvent. Solute decreases freezing point because disturbs crystal formation. Delta Tb is used to find molar mass. Colligative property gives molecular mass. Pi depends on number of solute particles, which gives maximum delta T of calcium chloride. Boiling point elevation is measured using ebullioscope. Colligative property depends on number of particles. Kf is numerically delta Tf over m. I increases with ionization. Pure water vapor pressure at 100 degrees Celsius is 760 mmHg. Osmotic pressure analogy is similar to ideal gas equation. Delta Tf depends on molality. Delta Tb increases with solute concentration. Isotonic solutions have same pi. Strong electrolyte gives higher delta Tf. Degree of association decreases with temperature increase. Electrolytes show abnormal molar mass. Osmosis is movement of solvent from low concentration to high concentration. Colligative property example, osmotic pressure. Vapor pressure of solution is less because solute reduces escaping tendency. Colligative properties apply to dilute solutions. Okay, it's all about some MCQs are related to colligative properties in chemistry. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. Let us know. Bye bye. So